Global unicast addresses. The most significant IPv6 addresses are global unicast addresses. These addresses are publicly routable addresses that can be used in the Internet. This figure shows the generic structure of the global unicast address. As you can see, the 128 bits are divided into three parts: global prefix, subnet ID, and interface ID. The global prefix can be obtained from regional Internet registry, and the prefix is called in this case provider independent, or it can be obtained from local Internet registry, and the prefix is called in this case provider aggregate, PA. A typical site, for example an enterprise network, will take /48 or shorter for the global routing prefix. /48 means 48 bits for global prefix, 16 bits for subnet ID, and 64 bits for the interface ID, according to IANA, which is responsible to delegate Internet services globally. And regional Internet registry will get a /23 or shorter for the global prefix, and a local Internet registry will get a /32 or shorter for global prefix. A shorter prefix means more available address space. Global unicast addresses assignment. An interface can be assigned a global unicast address manually or dynamically. Manually configuring a global unicast addresses has two options. Number one, static configuration, which is similar to configuring a static IPv4 address. The IPv6 parts, prefix, and the interface ID are configured on the interface. Number two, IPv6 and number, which is the same in IPv4 and IPv6. It allows an interface to use the IP address of another interface from the same device. The global unicast addresses can also be configured dynamically, and there are two options to do that. Stateless or address auto-configuration, or SLAC for short. Using this method, the interface ID is created using the Extended Unique Identifier, or EUI-64 for short. The global prefix length, and the subnet ID are determined from the router advertisement messages. The EUI-64 process uses the interface Ethernet MAC address to generate a 64-bit interface ID and combine this generated interface ID with the global prefix and the subnet ID, which is learned from the router advertisement message. The second option is using DHCP-v6 server, Dynamic Host Configuration Protocol. This is similar to that of DHCP for IPv4. A device can receive automatically its address information by using the services of a DHCP-v6 server. Whether the global unicast address is created automatically or manually, before a device uses its address, it will perform duplicate address detection, DAD for short, to make sure that it is unique on the link. The auto-configuration, which is used for dynamically unicast address assignment, can be a stateful service or a stateless service. The difference between stateful and stateless services is that the stateful service remembers the state of the client from one request to the next, while a stateless service does not keep any information about the state. In a stateful service, the DHCP can be used, and in this case, the DHCP is called stateful DHCP server. The stateful DHCP server must maintain an accurate listing of available addresses so that it does not give out duplicates. While in the stateless services there are two methods, Slack and stateless DHCP v6 server. In the stateless service, the interface depends upon the configuration of the routers. Router messages can be configured to instruct the interface to use stateless DHCP v6 or Slack. As you can see, the DHCP v6 could be used as a stateful service or as a stateless service.